about adding fractions, but to start off, we're going to talk about the parts of a whole definition. And in our definition, the whole is divided into B equal parts, and B is our denominator. And then we're going to consider A of them, and A being our numerator. So an example that I'm going to use today is we're going to talk about 2/3. And so we're going to divide our whole into 3 equal parts and consider 2 of them. Okay, so the next thing I want to talk about is a misconception. And the misconception I'm going to talk about is adding fractions with different denominators straight across. And I think the reason for this misconception is because whenever we learn about adding fractions, we start off with the same numerator. And whenever we add fractions with the same numerator, we can add straight across. But whenever we change the numerator, definitely meant the denominator. But when we change the denominator, we need to find them into like terms so we can add straight across. And I think kids want to automatically add straight across no matter what the fraction's denominator is, because they learned with like the same denominator adding straight across. I don't know if that makes sense, but anyway, so we're going to go ahead and get started with our problems. And I'm going to start off with the area model. And our problem is Sam was baking a cake and a batch of cookies for a bake sale. He needed 2/3 a cup of sugar for the cookies and 3/4 a cup of sugar for the cake. How much sugar does Sam need for the bake sale items? So to start off, he needs 2/3 a cup of sugar. So on our graph paper, we're going to divide or take a box and make it into 3 equal parts, because the whole box is our whole, and the denominator is what we're dividing it equally into, and we're considering 2 of those 3 equal parts. So I'm going to shade in 2 rectangles, and then we're adding 3/4 a cup of sugar. So we're going to add, and with our second box, we're going to divide it into 4 equal parts, and we're considering 3 of them. So we're going to shade in 3. And since our denominators are different, we're going to need to combine them into a like denominator. And we can take our box that's divided into thirds and divide those thirds into fourths. And we can do the same with our fourths and divide those into thirds, giving us a whole of 12. So now that we have our whole of 12, let's do our math here. So we're going to draw our 12. And we can see that 2/3 is 8/12. So we're going to shade in 8 boxes. And 3/4 is 9/12. That's one color. And we're going to shade in 9. But we only have 4. So we're going to need to draw another hole so we can get all of our cups of sugar in. And now we're going to, since we have 4 of our 9ths, we're going to do the other 5 over here. And that gives us 1 whole and 5/12. So the next model we're going to do is the linear model. And whenever we do our linear model with we're going to need to do a number line for each fraction. So our first fraction is 2/3. So we're going to label it 0, 1, and we're going to need to divide it into 3 equal sections. So this one is 1/3, and this is 2/3. And we're considering 2 of those thirds. So I'm going to draw a box around those 2. And then our next number is 3/4, so we're going to do the same thing. do a number line, label 0 and 1, but we're going to divide this one into 4 equal sections. 1/4, 2/4, and 3/4. And since we're considering 3 of them, I'm going to do a box with those 3/4. And we already know that we have to divide it again, like with our set or our area model, into equal or like alike terms. So we're going to divide our thirds into fourths and our fourths into thirds. And so we have our 12 giving us the 8/12 and our 9/12. And since we know that it's more than 1, we're going to make our number line go to 2. So I'm going to draw it all the way 0 over here and 2. And then 1, 2, 3, 4, 5, 6, 7, 8, 12 is this 1. And so we know that we need 8/12. So 1, 2, 3, 4, 5, 6, 7, 8/12. And then we need 9/12. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we have 1 and 1, 2, 3, 4, 5/12, giving us once again our answer of 1 and 5/12. And that's it. That wasn't even 6 minutes, was it?
My timer never even started. Check on the thing.